So as we all know, the area of the parallelogram is base times height. So let's get ahead and prove it. So this is a parallelogram right here. Draw a parallel line to the height right here. You see the height? The height is right here. This is the height. And this one is the base. Right here. So you draw a parallel line to the height and extend the base. So right angle right here. This must be a rectangle because as we know the bases are already parallel, and now we just draw two parallel lines, I mean the heights. So this must be a rectangle, and area of the rectangle is length is right here. Length, this top part, excuse me, length, and this part right here, and this is the height. So this is the base. So the area of the rectangle is length times height. So now we know that the rectangle area is length times height, and the length is, as we know, is the base. The height is, it's the same thing. So so we need this thing a few like later in the proof. So I'm gonna use the initial diagram again, the parallelogram with the heights and the parallel line to the height and this, but in a different way. Just now I said like this is a rectangle right here, and we put that aside. Now we are gonna prove these two triangles right here. This one and this one are congruent. Now here we have two triangles. This one and this one. And we also have this big middle figure. It's in trapezoid. It's right here, this part. So now we have three regions. So let's look at the two triangles first. Okay? So if you look at the two triangles, this must be a right angle, as we know. This must be a right angle because we know the height makes a right angle with the base. So these two must be congruent because opposite sides of a parallelogram, or as we know, are congruent. And we also know that in a rectangle, the opposite sides are congruent. So this must be congruent to this. So we have two right angles. As we know, right angles are congruent. I don't need to state that. So we have two right angles that are congruent, and we have one pair of legs that are congruent, and we have the hypotenuse. So by HL, we can say these two triangles are congruent. If you don't know what does mean, this is hypotenuse, H means, and L means leg. So we already know hypotenuse and leg are congruent. And if there is hypotenuse, there must be right angle, and right angle must be congruent. So I don't need to state that in the theorem. So if we divide this big figure into three regions, okay, let this triangle be region 1, this be 2, this triangle be 3. So we have three regions right here. And the area of the parallelogram, this thing is equals to sum of reason 1 and 2. You can see it, right? Mm. So now from just now we proved that this triangle area of this triangle is congruent to this triangle. This triangle is congruent to this, and so the areas must be equal. I don't need to state that. So we can say region 1 equals to region 3, area by 1 equals to 3. Now we have region 1 congruent to, equals to region 3, the areas. And the area of the parallelogram is sum of region 1 and 2. And area of the rectangle is sum of regions 2 and 3. You know, these two are congruent. We just know 1 and 3 are equal. So we can say that is equals to rectangle. You can substitute 1 instead of 3 because they both are the same thing. So if we notice that these two are the same values. So now we can say area of the parallelogram is the same thing as the rectangle. So from earlier in the proof, we knew that the area of the rectangle is length times height. We just said the length is nothing but the base of the parallelogram for the parallelogram. So it is base times height. So there we go. We found the area of the parallelogram and we just proved the whole thing.